To this problem section of Dalton's law of partial pressure. So two gases A and B having molecular weight 1645 gram respectively enclosed in a vessel. The weight of A is 0.5 gram and that of B is 0.2 gram. The total pressure of the mixture is 750 millimeters. Calculate the partial pressure of the two gases. So here we will apply the law of partial pressure. So what is the partial pressure of A? So partial pressure of A will be your mole fraction into total pressure. So it is given here. So what is the mole fraction of A? So mole fraction of A will be, you can see here, weight of 0.5 gram by 60. So we can write here this is a mole fraction of A. So 0.5 gram divided by molar mass of A is 60, and again we divide by the total mole fraction. So total mole fraction is we can see that total mole fraction means X mole fraction of A will be your 0.5 by 60 and divided by 0.5 by 60 plus 0.2 by next to your 45. See the 45. So this is the mole fraction. So we can write this directly here. So this is your 0.5 upon 60 plus 0.2 upon 45. So this is the mole fraction of, and what is the total pressure? The total pressure given here 750. So on solving we will get this answer is 489.23 millimeter. Now they are asking partial pressure of two gases. So this is the partial pressure of A. So what is the partial pressure of B? So total pressure is given here 750 minus 489.23. So we will get answer 260.77 millimeter. So this is the partial pressure of B. This is the partial pressure of A. So we have two answers. So equal weights of methane and oxygen were mixed in an empty container of 1 liter at 27 degrees centigrade. Calculate the fraction of total pressure exerted by oxygen as second is the total pressure if the weight of the gases are 32 gram each. So fraction of total pressure means we have to find the mole fraction of oxygen. So here in second, mole fraction of oxygen will be how much? So we know the weight is equal weight of methane and equal weight of oxygen. So we will take the weight of methane and weight of oxygen. So we can write here weight of oxygen we have to find out. So it is, that is 32 divided by weight upon 32 plus weight upon 16. So this is for methane, this is for oxygen. So on solving we will get here 1 upon 3. So this weight will be cancelled. Similarly weight of methane will be W upon, or we can subtract directly also here, weight upon 16 divided by weight upon 32 plus weight upon 16. So here we will get 2 by 3. So we can also subtract 1 minus 1 by 3 is also getting 2 by 3. So mole fraction of oxygen is 1 by 3. So this is the answer of A. Mole fraction of oxygen. What is the total pressure? So total pressure will be your total pressure will be your partial pressure of oxygen plus partial pressure of second is methane gas. Okay. So we can write here mole fraction of oxygen plus mole fraction of you can say methane gas. So this is the mole fraction, and again multiplied by RT. So this is the given a mole fraction because the total pressure is mole fraction of RT. So on solving, so you will get here 1 upon 3. So here is your not mole fraction, you write here moles of oxygen plus moles of methane. So this will be moles of oxygen, moles of methane. So moles of methane will be your, because they have given weight of gases 32 gram. So oxygen will be your divided by volume. Volume is 1 liter already given here. So oxygen is 32 by 32 and plus methane is your 32 by 16. And RT given, R is your 0.0821 multiplied by 300 divided by 1. So if you solve it, you will get directly here 73.89 atm. So all we have to solve it because every value is divisible. This will nothing but this will come 3 into 300 into 0.0821. So on solving you will get this answer. 1.47 liter of a gas is collected over water at 30 degrees centigrade and 744 millimeter of mercury. If the gas weighs 1.98 gram, vapor pressure of water at 30 degrees centigrade is 32 millimeter. What is the molecular weight of gas? So this is the your pressure of mercury, means total pressure is given here. So this is the pressure of the moist gas. So pressure of moist gas is 744 plus we have to find the pressure of the water vapor. So water vapor is also given here 32. Okay, so dry gas will be your, so moist gas is, this is the moist gas, so this minus pressure of dry air. Now this is the total pressure of moist gas. So this is nothing but this is equal to pressure of dry air plus aqueous tension of water. Aqueous tension of water. So here pressure of dry gas will be, pressure of dry gas will be 744 minus 32. So we will get answer 712 millimeter. Now we have to find the molecular mass of the gas, means which one of the gas. So we know the pressure of dry gas this much, so we can write here PV equal to nRT. Use the ideal gas equation because from here we will get the molar mass. So pressure is given here 712 beta 7 upon 760. Volume is given 1.47 liter. 1.47 liter. Weight is given, so weight is again 1.98 gram divided by molar mass into 0.0821 into temperature is 30 degree, means 30 plus 273. So on solving, now we can solve it. So if you solve it, you will get molar mass 35.76 gram per mole. So this is our answer. 50 liter of dry nitrogen is passed through a 36 gram of water at 27 degrees centigrade. After the passage of gas, there is a loss of 1.2 gram of water. Calculate the vapor pressure of water. So this is this amount of water is present in the vapor form in the this much volume. So volume is given, weight of the water vapor in the this atmosphere also given, temperature given, and it is passed to 36 gram of the water. So this is again, so no use. What is the vapor pressure of water? So again we can use the ideal gas equation. So from the ideal gas equation, so we know that PV equal to N into R into 2. So pressure is given how much? So pressure we have to find out. So pressure of water, volume is given 50 liters. So this much space is occupied by the water vapor, and how much weight is there? So weight is 1.2 gram. Molar mass is 18. R is given here 0.0821 and temperature is 27, means 300. So now we can solve. So pressure of the water on solving, you will get 0.03284. So this is the in millimeter. So okay, so we have to convert this as this one to convert. This is the your atmosphere pressure. This is atmosphere pressure. So convert to millimeter. 3284 into 760. So you will get in 24.95 millimeter. So this is the pressure of water in millimeter. So both answers are also correct. This also correct. This also correct. A liter flask contains air, water vapor and a small amount of liquid water at a pressure of 200 millimeter mercury. If this is connected to another 1 liter evacuated glass, what will be the final pressure of the gas mixture at equilibrium? Assume the temperature to be 50 degree and aqueous tension of water at 50 degrees centigrade, that is 93 millimeter mercury. So here we have two flasks. Okay, this flask is connected with another flask, but this is evacuated. So this is evacuated, this is connected with stop coke. This is also 1 liter, this is also 1 liter. So volume is also 1 liter. So when you remove coke, so this gas is vacuum. This gas is filled with the pressure is how much? So this is given here 200 pressure millimeter and plus water is 93 millimeter. So total pressure is given here over here. This is the pressure of the water vapor. So when you remove this one, so this gas will go from here to this one. So after going this one, what will happen? The vapor pressure of the both will be equal to each other. So first we will find the pressure of this much, that is it is following the gas laws, Boyle's law. So they will follow the Boyle's law. So Boyle's law is P1 V1 equal to P2 V2. So first we will find the what is the atmospheric pressure of the dry gas, because water is also present here. So pressure of the moist gas is 200. So definitely pressure of the dry gas will be 200 minus 93. So we will get here 107 millimeter. So now we can use the this one gas laws, because after gas laws some water will also go with this one. So first we will find the pressure of dry gas, then we will add the aqueous tension water. So this will be the final pressure of the water. So this is the pressure of the dry gas will be this much. So apply the Boyle's law. So pressure with P1 V1 equal to P2 into V2. So this is the initial, and this will be your after opening the stopcock. After opening stopcock. So pressure is how much? So pressure is given here 107, volume is 1 liter, and P2 we have to find. This is the final pressure, and this volume is 1 plus 1. So P2 will be 107 divided by 2. So you will get here 53.5 millimeter. So what is the final pressure? This is the dry gas. This is the dry gas. So here some water vapor is also there. So pressure of this moist gas will be total pressure is 53.5 plus 93. So you will get answer 146.5 millimeter. So this is the answer, which is the final pressure in both the vessel or both the flask. 5 liter of water is placed in a vessel of 5 into 5 into 1 cube at 300 Kelvin. If vapor pressure of water is 27 millimeter and density is 0.99 gram per centimeter cube, how much amount of water will be occupying gaseous state and how much in liquid state? So there are two, say 1% in gaseous state, 1% liquid state. So liquid state, we know the total weight of the water is this much, 5 liter into density is there. So first you find moles of water occupying gaseous state, so that will be how much? So that is the state are having vapor pressure. So vapor will be same only. Same means how much? 27 millimeter. 27 means 27 into 10 to the power minus 1. So this is the millimeter is there. So we are converting to centimeter. So this is centimeter. This is the vapor pressure of water vapor. So we have to find the moles. So moles of water vapor will be how much? Pp by RT. So what is the pressure? Pressure is given. So 5 into pressure is given here. 5 in, this is the volume is given. The vapor pressure is this much. So 2.27. So this is the pressure 2.7 centimeter divided by 76. And volume is given. This is the volume 5 into 5. 5 into 5, that is the 25. What is the R? R is the 0.0821 and temperature is again 300 Kelvin. So right here 300. So on solving you will get 36 moles of water. So this is the water present here. So in vapor form, so weight of water will be 36 into 18, that is the 648 gram. Now original mass of water is how much? Original mass of water is the total volume is given here, that is the 5 liter. So take 5 liter, 5 into 10 power 3. So this become meter cube. And now we have given here centimeter. So this is the density of air. This is the volume and multiplied by density. So what is the density of air? So air density is 0.990. So this becomes centimeter. So on solving we will get 4950 gram. So this is the total mass of water. Now mass of water in liquid state. Mass of water in liquid state. So definitely, so this is in vapor state, this is liquid state, this is vapor state, this is vapor state. So this is 4950 minus 648. So we will get liquid in 4305 grams. So this is in liquid state. So there are two answers there, this and this. So this is our answer of this question. A flask each of capacity 1 liter containing ammonia at 1 atmospheric pressure at 25 degrees centigrade. So 1 liter of ammonia, and this is the pressure and temperature. A spark is passed through until all the ammonia is decomposed into nitrogen, hydrogen. So you have to calculate the pressure of gases left at 25 degrees centigrade. Means we have three gases, nitrogen and hydrogen. So what is the pressure of nitrogen, hydrogen formed, and what is the pressure of that gases left at 25 degrees centigrade? So we have to find the ratio of two gases. First you write equation. Ammonia is converting into nitrogen plus hydrogen. So balance it. This is the 3 mole, this will be 2 moles. This is the balanced equation. So now we have given what is the moles of ammonia. So moles of ammonia will be how much? So agar PV by RT, so PV by RT, so PV is equal to how much? So pressure is given 1, volume is 1, R is given 0.0821 into 298. So on getting, we will get 4087 into 10 to the power minus 2. So this is the moles of ammonia. Now you can see here 2 moles of ammonia are used. Here 2 moles of ammonia are used, and 4 moles of nitrogens and 3 moles of hydrogens are formed. So this is given here. So you can see here 2 moles of ammonia used, and we will get here 1 mole nitrogen and 3 mole hydrogen. So total is the 4 moles of, we can say, gas. So 4 mole gas means 2 gas, nitrogen, hydrogen. So now we know that at what constant temperature and volume. So pressure is directly proportional to number of moles. So this we know from the equations, ideal gas equation, we know that. So we can write here P1 by P2. This we can write P1 by P2 equal to, so P1 means we are having 1 atmospheric pressure, so right here 1, and P2 will be how much? It will be your P1 by P1 is equal to N1 by N2. So this implies that, so P1 is 1 and here P2 is final pressure. After the pressure we don't know. So in case of P1, what was the number of moles? This is for the ammonia, this was 2, and after that this is the 4. So initially pressure was 1, so here initially pressure was 1 atm, and after we don't know the pressure of P2. So this is the pressure of ammonia and this is the pressure of nitrogen and hydrogen. Initially ratio was 2 moles, so this is the ammonia is 2 mole, and after the decomposition it becomes 4 moles. So this is the ratio. So we can write here pressure after dissociation is, after reaction is 2 atmosphere. So it becomes doubled. Now we have to find the moles of ammonia. So to find the moles of ammonia, not moles of nitrogen. So moles of nitrogen found will be this is the mole fraction. So initial pressure was how much? 1 by 2 into mole of ammonia. So why 1 by 2? Because this is here initially was 1, then we had 2, so 1 by 2, this is 2 atmosphere, initially 1 atmosphere, the fraction of pressure into moles of ammonia. So we will get answer 1 by 2 into 4.087 into 10 to the power minus 2. So we will get answer 2.0435 into 10 to the power minus 10. So this is the one we are taking atmosphere, this is taking atmosphere. So it is the final atmosphere, this is the initial atmosphere. So 1, it was the 1 atmosphere, and after this 2 atmospheres. So 1 by 2 is equal to this much given here. No, it is not 1 by 2. Sorry, this is not moles. This is the 1 mole of nitrogen. This is 2 moles of ammonia. So 1 mole by 2 mole. So it becomes the moles of ammonia. This is the total moles of ammonia. So 1 by 2 divided by total mole of ammonia. So similarly, moles of hydrogen will be how many hydrogen? 3. So right here 3 divided by this, how much mole ammonia? 2, and multiplied by 4.087 into 10 power minus 2. So we will get answer 6.1305 into 10 to the power minus 2. So this is the 3 is the moles of hydrogen, 2 is the moles of ammonia, 1 is the moles of nitrogen, 2 is the moles of ammonia. So this is the moles of nitrogen, this is the moles of hydrogen formed after the reactions.